So today we will start with maths. Okay, and in this lecture we will cover the first topic of math, which is priming. Okay, so what we know that what is basically a prime number? Okay, so prime number is a number which is divisible by 1 and itself. Okay, so it has been given in the question that a prime number is a number that is greater than 1 and has only two factors which are 1 and itself. So what we have to understand here is that if there is a prime number, then 0 and 1 is not prime, and the smallest prime number is 2, and 2 is the only even prime number. Okay, so any number is a prime only if it is divisible by 1 and itself. So in this question, we have given a number and we have to tell that, okay, if this number is a prime or not. So what we do here is that, okay, we have given n is equals to 7 and we have to tell that, okay, if this number is prime or not. So what we will do that, okay, what I know that if this number is prime, then it has been divisible by 1 and itself means 7. So what I will do, I will left this 1 and left this 7. And after that, what I will do, I will try to divide this 7 with all the number in the range of 1 and 7. So I will start from 2 and then take 3, 4, 5, and 6 and try to divide uh, this 7 with all of this number. So if any of this number will divide that 7, so it means that this 7 is not a prime. So what does it mean that this number divides 7 or not? So if you see that if I divide it by 2, I got 3.5. So I will see that, yeah, 2 divides 7. No, not this. Actually, we have to check that what is the remainder after dividing it with 7. So this number will divide this number only if we get remainder is equals to 0. Right. So let's try to divide. So if I divide 7, what I will get? 6 and then 1. We get the remainder is equals to 1. Now if I divided it with 3, you will see I got the remainder is equals to 1 again. Now if I divided with 4, you will see I got the remainder is equals to 3 here, right? 3. So all of this number like 2, 3, 4, 5, or 6 will give me some remainder. And till that time, I will not get the remainder is equals to 0. It means that that number will not divide that number. So I only have to check this. So what I will do, I will start from 2 and go till which point 6. So so what is basically this 6? So if n is equals to 7, this is 6. If n is equals to 14, then this must be 13. So if n is equals to n, then this must be n minus 1. So I will start from 2 and go till n minus 1 and try to divide each number with that particular number and check the remainder. So to check the remainder, there is an operator called modulo operator, and this is used to find the remainder. Okay, used to find the remainder. So if I want to know that what is the remainder of this, if I divide it with I. So what is I? I will be from 2 to n minus. So you have to know the basic C++. You can watch lecture from anywhere, or you can learn it from GPT also. Okay. So you only have to learn the loops, if else, uh, basic array implementation. Okay. And that's it. And you also, if you want, you can also learn the object-oriented programming. Or if you don't want to watch lectures, you can prep for GFG documentation. You can uh, learn that language from that reading documentation. Okay. So if I see that, okay, if I divide uh, n by I, if I get the remainder is equals to 0, it means that basically this n is not a prime number, because what I know that n is a prime number, then it is only divisible by 1 in itself. But what I have seen here is that okay, I will never take 1 or I will never take n. The number will be from 2 to n minus 1. And I will see that okay, any number between 2 to n minus 1 will divide this n. It means that there is third factor which divides this n. So if I got a third factor, it means that this number is not a prime number. So what is this number? So this number is basically composite. And till last, if I not find any of the number which divides this n, it means that this is basically a prime number. This is basically a prime number. So what is the time complexity of this? So if we see, the time complexity will be end minus start. Just learn this for now, and we will study about time complexity in future classes. Okay, so what is end minus start? So this end is that till where we have to go. So I have to go till n minus 1, and sorry, n minus 1. And from where I have started. So I have started from and just write big. So big O of n minus 3. Or we can also write it as big O of n, because this constant factor will be removed. So I will get the time complexity is equal to big O of n. Now let's try to write the code. So if you see here, we will use bits slash using namespace. And now I will call a function. So in the question, it is given that we have to take the input by ourselves, and the input has the range from 2 to 10 raised to power 5. So we can take an input. So how can we take an input? So int n and c in n. So this is how we can take input. After taking the input, what we have to do, we have to check. If I see that, okay, n is less than equals to 1, so basically this is edge case. What I know, if I get either a 0 or a negative number or a 1, they are basically not prime. So I will print that, okay, no, this is not a prime number. Okay, and I will terminate the function here because I don't have to check another lines. Okay, otherwise what I will do, I will start the loop from 2 and goes till n minus 1. Okay, and now what I will do, I will check that, okay, n modulus I is equals to 0. If this is equals to 0, what does it mean? This number is not a composite number, not a prime number. So what I will do, I will simply return no. Okay, this is not a prime number. And otherwise, what I will do, I will return that, okay, this is a prime number. So for prime number, I have to print yes here, and I will return. So let's try to submit this code. Like this. One prime is there. Yeah, the code has been accepted, right? So basically, I recorded the lecture a few hours before or few minutes before, basically. But I am not inserting the earphone, so that's why the sound has not been recorded. I already completed the whole optimization part, but the sound has not been recorded, so I record this lecture again. So let's see the optimization, and okay, so we will see the optimization in next lecture. Okay, till then, take care. Bye bye. Good night.